To the BH1750 test edit sketch, I added functionality to cryptographically sign a message. The float to byte function takes a float lux and populates a message array with the byte equivalent in hex. atech.createSignature creates a cryptographic signature with the message using the private key on the Cryptographic Co-Processor. Here's the output. You can see the float value from the sensor value converted to a 32-byte array message in hex, and the 64-byte array formed by cryptographically signing the message with the private key on the Cryptographic Co-Processor, forming a cryptographic signature. The code to convert a float into a byte array with a float to hex.h header and float to byte function takes advantage that a float and in union with a struct with 4 unsigned char, each size 1 byte, occupy the same memory location. The SparkFun X08A Ardunio library was modified by me with an August 26th version. In the header file for the library, the ARTCC508A max request size in the receive constant section was changed from 32 to 96. The ATEC508A address default was kept constant at the hex address 60. Sometimes this address needs to be changed when the SparkFun library examples say device not found, check wiring, when there is not a loose wire to the cryptographic coprocessor. The I2C scan script for the CubeCell can be used to diagnose this. As an experiment, I connected an 8-channel logic analyzer to the SCL, SD8, and ground connections of the cryptographic coprocessor. I hope I correctly chose D0 and D1 for the SCL and SD8 connections in the PulseView software for the logic analyzer. Unfortunately, the SparkFun code only writes to the serial connection. In the future, I would like it to output to the LoRa transmitter on the CubeCell. I believe this will require modifying the SparkFun X08A Ardunio library. The create signature function and the load temp key and sign temp key functions that it calls may need to be modified to return an array which contains a cryptographic signature in addition to or instead of the Boolean values, which changes with success and failure of the functions. This array can then be sent over the LoRa connection, perhaps with the array containing the message as well as the array containing the public key. Perhaps these arrays should be converted to a string. I'm not sure about the protocol. This data should be able to be ingested by the Node.js server at the WebSocket endpoint.